Hey guys, Dr. Brown here with Kubo Math, and tonight we're starting a series on integration of various sine cosine functions where we're looking, in this case, the integral of sine to the second power. Now in another video we'll look at sine to the third power. But as I'm walking through just calculating, practicing math every day, I thought, well, why don't we just develop the integral of sine to the n for any n 2 or greater than that we would have that. So that's what the series are going to be about. We'll end up doing sine squared, next video sine cubed, the next video sine to the n. Now I would put the three together, but there's two reasons no. I have spinal stenosis and I can only stand up for about 15 minutes. So that's why you see very limited time on videos. And then secondly, the issue would be if I did sine squared, sine cubed, and sine to the n, it'd probably take me about 25 to 30 minutes. And you would fall asleep way before we got to that. So all right, just know there's going to be 3 videos out there, okay? All right, so let's look at this one. We know that sine squared, that could be 1 minus cosine squared. But if we were to use that, we would have the integral of 1 minus cosine squared x dx. And what would that give me? The integral of 1 dx minus the integral of cosine squared x dx. So now I end up in the same dilemma that I have now. What to do with the squared term there when there's no derivative of that function. So we utilize concepts of power reduction. So that works a little bit better for us. So how can we change that formulation? Well, there's a formula out there that says sine squared x equals 1/2 minus 1/2 cosine 2x. And we're integrating that with respect to dx. So you can see I've reduced the power, and now I have something I can absolutely work with, not a problem. So let's separate this into 2 different integrals. And by the constant power rule, we can pull this 1/2 to the outside. So I have 1/2 dx, that integral, the integral of 1/2 dx minus the integral of 1/2 cosine 2x dx. Well, we know the integral of 1/2 dx is just 1/2 x minus 1/2 the integral of something. It's a bad looking integral sign. Cosine 2x dx. Well, let's work with the inside. So let's let u equal 2x. du equals 2 dx. Now if we isolate the dx, we divide both sides by 2, so I'd have du over 2 equals dx. So now we have minus 1/2 the integral of cosine u, and we're replacing dx with du over 2. du over 2. Well, now I have this 1/2 here, so let's rewrite this. 1/2 x minus 1/2 times 1/2, 1/4, the integral of cosine u du, and that equals 1/2 x minus 1/4. The derivative of cosines minus sine. The integral is sine, so sine u, but u is 2x plus c. I know this is a short video. They'll get longer as we go up to a point. So the integral of sine squared x dx is 1/2 x minus 1/4 sine 2x plus c. As I mentioned, our goal is to look at this exponent at 2 and 3, get what to solve for those functions, and then do that sine to the n. But I'd like to repeat that same concept with cosine squared, cosine cubed, cosine to the n, tangent squared, tangent cubed, tangent to the n, cosecant, secant. Just walk through the different functions and have those in our toolbox for use in the future. Okay guys, why are we doing this? Together we're trying to build a better tomorrow and do that through math. So study, 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 and let's practice and let's make a better tomorrow. That's all for now. We'll talk to you next time. Stay tuned. See you.